Next, we're going to move on. We're going to move on to something which is a little theoretical, which is the mean value theorem. And that will allow us in just a day or so to launch into the ideas of integration, which is the whole second half of the course. So let's get started with that. The mean value theorem will henceforth be abbreviated MVT, so I don't have to write quite as much every time I refer to it. The mean value theorem colloquially says the following. If you go from Boston to LA, which I think a lot of Red Sox fans are going to want to do soon. So that's 3,000 miles. In 6 hours, then at some time, you are going at a certain speed, the average of this speed. Average. So speed, which in this case is what? So we're going at the average speed. That's 3,000 miles times 6 hours. So that's 500 miles per hour. Exactly. So sometime on your journey, of course, some of the time you were going more than 500 miles an hour, sometimes you were going less, and sometime you must have been going 500 miles an hour exactly. That's the mean value theorem. The reason why it's called mean value theorem is that word mean is the same as the word average. All right. So now I'm going to state it in math symbols, the same theorem. And it's a formula. It says that the difference quotient, so this is the distance traveled divided by the time elapsed, that's the average speed, is equal to the infinitesimal speed for some time in between. So some c, which is in between A and B. I'm not quite done. It's a real theorem. It has hypotheses. I told you the conclusion first, but there are some hypotheses. They're straightforward hypotheses. Provided f is differentiable, that is, it has a derivative, in the interval a less than x less than b, and continuous in a less than or equal to x less than or equal to b.